All right, we are going to do the chain rule. And the chain rule is something that you will now think of every single time you are doing derivatives. And so here's the thought behind it and what I want us to look at. Is the derivative, and you just write this at the top of one of your sheets, of 5x plus 3, if I wanted to find that derivative, is it okay for me just to use the power rule? So can I just go power to the front, decrease the power by 1, so I end up getting 10x plus 6? Is that going to be my derivative? Well, you certainly could say, well, with that one, since it's just squared, instead of writing and using the power rule, I could square that out. I could square out that binomial, and I would get this, and then I'm able just to take the power rule, and I get 50x plus 30. So I see that this and this are not the same. So it's like, okay, so the power rule didn't work. Well, the issue is, it's not that the power rule didn't work, it's just you have to understand that when we did the power rule, the derivative of what you were raising to the power was 1, and when that's not true, you always have to think of that inner derivative. Look at the difference between these two. If I 10x plus 6, 50x plus 30. Notice if I did 10x plus 6, which was the power rule part, if I multiplied by the inner derivative, look at what I'm taking, raising to the power. If I took that derivative, which would be 5, notice I get the 50x plus 30, and that's the derivative I should have gotten. Now I'm going to give you a formula, okay? I'm totally going to give you a formula, but because in some problems you have to know the formula. But I want you to understand that you can use this. Don't make it complicated. You just have to think of it as layers, and that's why the M&Ms, okay? You have layers. If you have a plain M&M, you have a shell and you have a chocolate. If you have a peanut M&M, you have a shell, a chocolate, and a peanut. Well, today we're only going to deal with plain M&Ms. We're only have 2 layers, and you have to see this as a composition. So if I ask you to take the derivative of 5x plus 4 to the 6th. Okay, well, here's the deal. I can't just do the power rule part. So I have to look at it as layers. The outside function is going to be what? The outer function is something to the 6th power. The inner function is 5x plus 4. So it is a composition. Now, I don't have a peanut because, again, I only have 2 layers. But if I wanted to find the derivative, what you have to think of is take the derivative of each piece. So if I want to do a power rule, I'm going to do 6 power to the front, decrease the power by 1. And then I'm going to multiply by the derivative of this guy, which would be 5. Now, what goes in this parentheses right here? The same thing that was in this parentheses. And almost like if you're setting up in a chart, it's whatever this next guy over is, which would be 5x plus 4. Now, of course, to clean that up, I could multiply the 6 and the 5, and I would get 30, 5x plus 4 to the 5th. And that would be my answer. Just getting rid of some of this writing so I have space. Let's try another one. Let's look at if I had x squared plus 3x plus 9, and I wanted to do that to the 7th power. Think about your 2 layers. I have something to the 7th, and then my inner function would be this. And so how do you take the derivative? You do the derivative of each section. So I'm going to do power to the front, decrease the power by 1, multiply by the derivative of this, which would be the inner derivative. And of course, what goes in this parentheses? Whatever you were raising to the power. So that's going to be, I'm going to have to write tight, the x squared plus 3x plus 9. Very messy, but you get that my answer would be, I could whether they multiply that out or not, I'm going to go ahead just in case they do. 14x plus 21, just distributed that 7 with that, and then this, that's not a plus, and then this part they certainly would not multiply out. I would have x squared plus 3x plus 9 to the 6th. And that's my derivative. So hopefully you're kind of seeing the idea. Now I am going to erase so I have just plenty of space. Plenty of space. And let's look at this next one. What would happen? It's hard for me to write in these little bitty boxes. All right. What would happen if I ask you for the derivative of this? Negative 7 over 4x minus 9 to the 3rd. Okay. Well, let's think about rewriting that. Let's rewrite that. That's, if we rewrote it, we would have negative 7 times something to the negative 3rd. Now, what's that something? 4x minus 9. Notice I didn't move, the negative 7 is not being raised to the 3rd. Okay, so let's take the derivative of each piece. Here we go. Power to the front, so that's going to be a positive 21. Power to the front, decrease the power by 1, so that's going to be negative 2. Oh no, be careful. Decreasing the power by 1, that would be negative 4. A lot of people with negative exponents mess up there. That's going to be a negative 4. You're subtracting 1. So negative 4, that's decreasing the power by 1. Now multiply by the inner derivative, which would be times 4. Of course, this is 4x minus 9. What's in the parentheses doesn't change. And so for my final answer, what do I get? How could I write that neatly? 4 times 21 is 40, no, that would be 84. 84 over 4x minus 9 to the 4th. And last one, let's do one more and then we'll go to our worksheet. And some people kind of set up these as boxes. I'll talk about that in a minute. But as you get better, I hope that you see, I'm kind of saying something, which is what I say in my head. Every time I'm doing the power rule, what I now say in my head is power to the front, decrease the power by 1, multiply by the inner derivative. It's just, it's what I talk to myself when I'm doing math, and that's what I say in my head. So let me show you on this next one. Again, I've been saying it, but let me continue to say it as we go. So let's look at this one more, and then we'll say the other 3 boxes for the next day. What about the square root of x squared plus 1? Well, what is that really? The inner function is x squared plus 1. The outer function is something to the 1/2. So again, what do I say in my head? Power to the front, decrease the power by 1, multiply by the inner derivative. And this is x squared plus 1. And so what happens? If you clean that up, look at what happens. This 1/2 and this 2 cancel, so I end up getting, write it small in your box, x over the square root of x squared plus 1. And that's that derivative. So what was the formula? I mean, what we were really doing, if you looked at F and G, here's what the formula actually is. And let's see if I can find, let's see, where's my other sheet? Okay, so what did we do to get that derivative? When we had the outer function and the inner function, we took the derivative of the outer function and evaluated at the inner, but we didn't stop there. We said times the inner derivative, or g prime of x. That's the actual formula for the chain rule. Now, I'm not saying, I'll be honest, when I'm doing the power rule, I don't think of that formula. But I promise you, you have to know that formula because I will test it in some way, and so does AP. They do it with charts where you have to know that formula as well. So you try example 1, either how you do it in your head or you set up a little chart. Now, granted, you're not going to have a chart on all your homework, but some people they literally set up a chart and they put like the outer function and they put the inner function and they think through and they do the derivatives of each and multiply them together. If you like to do that, if that helps you visualize it, then by all means do that. If it's a power rule, again, I'm a wordy girl. So again, I would say, oh, it's power rule. So every time I do power rule, I just think to myself, power to the front, decrease the power by 1, but I can't stop my thought there, times the inner derivative. So I look at this inner parentheses and I go, what's the derivative of that thing? And that would be negative 8x. And so my final answer for f prime is going to be negative 56x times 3 minus 4x squared to the 6th power. So hopefully you're getting fast at that. But you know, it gets a little crazy. Because let's look at this next one. Find f prime if f of x is that thing. Whoa, 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 whoa. So you're telling me I have x squared times something, so I'm going to have to do the product rule. Oh my gosh, and then I have to think a chain rule. Well, it's not and then I'm going to have to think a chain rule. It's as I'm doing the problem, I have to think of chain rule. So watch me as I do this one. All I did was rewrite the square root. So here is my first, here is my second. So f prime is going to be, now watch the product rule. The product rule is first times the derivative of the second. Now, as I'm doing the derivative of the second, that's where the chain rule is. I have to think power to the front, decrease the power by 1, but I can't stop there, times the inner derivative. So the inner derivative is negative 2x. That's the chain rule part. I'm not done though. This is first times the derivative of the second plus the second times the derivative of the first would be 2x. You have to think of chain rule. It's not something you think of at the end of the problem. It's as you're doing product, quotient, power, all those things, you have to think of it in the middle of doing your derivative. Now let's clean this up because I think it'll help you. With this guy, this 1/2 and that 2 cancel. So I really have negative x to the third, 5 minus x squared to the negative 1/2. This next guy, really not too much cleaning up. I just like to put that in front because I think it looks prettier. And you go, sweet. Yeah, not sweet, because they're not going to leave the answer like that. The answer is they're going to simplify it. So you have to practice this skill. Remember of pulling out what's common. So what's common? They both have an x. And some people go, well, do I factor out the negative or do I not factor out the negative? That really, you can tell that at the end, so don't get too confused on that of whether you should factor out the negative or not. So I'm not going to. I'll factor out an x. they both have a 5 minus x squared, and what power do I take out? The lower one, so that's negative 1/2. And what would be left? Well, for the first term, I would have to have a negative x squared. These powers are the same, so I don't have that factor. For the next term, I would need a 2, and I would need a 5 minus x squared to what power? Remember, when you multiply, you add these, and I have to get 1/2, so this would need to be to the first power. Now let's keep cleaning. Notice that every line equals. I don't get lazy. What is this parentheses? Negative x squared plus 10 minus 2x squared. And now I could go to a final answer. I have the x. I'll put him there. They don't usually leave negative exponents, so I'm going to take the 5 minus x squared and put on the bottom. That would be to the 1/2 power. Usually with 1/2 and 1/3, they put it as a root. So I'll slap a root in there, a square root. And then this factor will go on top, 10 minus 3x squared. And that's my final answer. Again, if you had pulled out the negative x, then this would have been 3x squared minus 10. Sometimes they distribute that at top. Again, that part I'm not too concerned about, but I promise you they will not leave it like this. You have to get down to a product and a quotient. Cool? Awesome. Let's look at the last one. The last one is the same idea, and I will tell you, you can work this 2 ways. Now, I work it as a quotient. I actually think the quotient is easier. If you do a product, you're going to have to rewrite it and put it to a negative exponent, and people, to me, sometimes mess up with that. So for consistency, I want you to stop the video, and I want you just to try to do the quotient rule. And then come back and see if you get it right. So this guy is my high, that guy is my low or my ho. So here we go. We have ho, d high, so that's times 1. Obviously you don't have to write that. Minus high, d ho, the derivative of the bottom. Power to the front, decrease the power by 1. But you can't stop there. Times the inner derivative. You cannot forget the chain rule part. Over ho squared. Well, if I squared that, remember, power to a power, I multiply. So that would be x squared plus 2 to the 6th. Now let's clean up, shall we? You're like, okay. How do we clean that up? Well, let's look at this, and if it's okay with you, I think you can follow me, because if you look at those 2 terms, I'm just looking in the numerator. Let's just focus our eyes right here at this, and I'm not even going to clean it up. If you like to multiply that all out like I did in the last one, that's fine. Sometimes I don't even do that step because I'm just going to clean it up. Look at your 2 terms. You have this and all of this. The only thing I could pull out is an x squared plus 2 squared. Now what would be left? Well, this first one, this times 1 is not even doing anything. So I would have an x squared plus 2 to the first power minus, because I have a negative right here. Now this guy I've pulled out, all of this other stuff would be remaining. What really is there? I can just multiply it out now. 6x squared. Now I still have over x squared plus 2 to the 6th. Well, let's get a final answer, shall we? Well, gosh, if I have x squared plus 2 squared on top and x squared plus 2 squared to the 6th on bottom, couldn't I go, well, that could go with there and I'd have 4 of them. So my x squared plus 2 to the 4th is going to be on bottom. And if I cleaned up this guy, I could just add like terms. So I'd have 2 minus 5x squared. And that's really all I can do, and that is my derivative. If you chose to do product rule, again, you could move that to the top, but you are dealing with negative exponents, but you would get the same thing. Okay, you would get the exact same thing. They just wouldn't write the answer with negative exponents, so you'd have to clean it up. And like I said, I have found that people usually mess up with that. So don't be afraid of the quotient rule. I think to me, it's easier. All right, so practice, practice, practice the chain rule. Okay, it's going to take your practice. Think of it now and forever. Every time you do the product rule, please think of the chain rule as you are doing it. Every time you're doing the power rule, please think of the chain rule every time. The question is the inner derivative 1? And if it's not, you have to remember to multiply by that. And sweet friends, you have to practice this tonight, because tomorrow when we do this with trig, if you haven't done this, you're going to be so lost. So please practice, and we'll see you later. Peace out.